Okay, good afternoon once again. Today we're going to continue our discussion on machine learning. So far, what we have learned in machine learning is classification. Okay, the supervised learning called classification, and we looked at supervised learning, in particular classification and regression trees, CART, what we call the CART models, CART, classification and regression trees. Okay, so recall, let's have a quick review. Decision trees is just a type of supervised learning. Okay, supervised learning that can be used in both classification and regression. That's why it's called CART, classification and regression trees problems. Okay, it can work whether your variable of interest or dependent variable is categorical or continuous. It can also work if your independent variables are categorical and continuous. So in both cases, it can work. Now, decision trees are relatively very easy to understand and easy to explain. Because if you have the tree, it's how we think. When we try to classify things, if it belongs to this one, this criteria, then you choose this one. Otherwise, you choose this one. Okay, as I said here, they closely mirror or imitate human decision making compared to other regression and classification approaches. That's what makes CART very, very popular. It mimics how our brains think. And another advantage is that you can create a graphical presentation of your model. Okay, so whether your predictors are qualitative or quantitative, okay, we can make use of that. However, there's a limitation here. They do not have the same level of predictive accuracy as other approaches, and they're not quite as robust as other approaches, okay, which we're going to learn on Friday. And they're very sensitive to a small change in data can cause a large change in the final estimated tree. Okay. Now, as I said, supervised learning, Tono. Can you please chat what's an example of an unsupervised learning? Can you check? Give me an example of unsupervised learning. As a matter of time, supervised, we have unsupervised, we also have reinforcement learning. But let's take a look at just unsupervised learning. Can you check? Check the internet, for example. What's an example of unsupervised learning? Give me at least 2 or 3 examples. Kindly chat, please. Example of unsupervised learning. Okay, dimension reduction, okay. What's dimension reduction, Carlos? What is it all about? Can you share to the class what you got from what does dimension reduction do?
So you have a bunch of unlabeled data.
Okay.
Then from a high volume of space, you try to minimize it to a lower dimensional space so that you can determine what the data presents and what pattern.
Okay. Right, dimension here can mean variables. So you have several variables. Usually you're working with maybe it can be hundreds of variables. So if you want to simplify this and maybe combine those some of these dimensions, you can do that. And that's what we mean by dimension reduction, to simplify the model that we're creating. Okay, thank you, Carlos. How about others, please? What are examples of unsupervised learning? It's important for us to know the difference between supervised and unsupervised learning. Another common example, yes, thank you, Julie. Could you kindly share to the class what clustering is and what does it do?
Clustering is yung grouping ang level examples also, and there are some data points na hindi pa label.
Okay, hindi pa, no?
Label.
Sorry.
Not yet
Label.
label.
Okay,
Yes.
so this is also unsupervised learning kasi walang label sa mga data. No? Unlike supervised learning, when the variables, the dimensions are labeled already. So clustering, that's used for, as the name suggests, you cluster, you group your data, your observations. So this is also good for, in the case of marketing, for example, what's the use of this clustering? You have your data, you can cluster your data in such a way that the attributes, those clusters have similar attributes. So if this is done in the context of marketing, then and let's say you're doing a promotional plan, so you can target a specific promo, a specific advertisement for those specific clusters. Because nowadays we know that it's not anymore possible to just have one type of, let's say, promotion or advertisement that's targeted for all people. Technology has now reached a level where we're able to cluster our data so that now if you're targeting a specific target market, then you can now design your promotional endeavors to that specific cluster, to that specific group. So you don't just create a promotional plan that's for everybody and that might not reach your specific target. Yeah, thank you, Julie. That's another type of unsupervised learning, clustering. Other examples, class? There are many examples of unsupervised learning. What else, class? Example? Unsupervised learning. Okay. Anomaly detection, John, can you kindly explain that?
Sure, it's when machine learning identifies unusual patterns or outliers in a data set so that the data would be smoother to analyze po.
Yeah, okay. But did you find that classified under unsupervised?
Yes po sir, since
Okay.
di naman daw po kailangan i-label since okay. Classify niya lang po yung malayo dun sa ibang data.
Okay. Yeah, the anomaly detection can also be used to supervise, pwede rin yun, no? But it's also, John is right, it can be used also for unlabeled data. Okay? All right, one last example ng unsupervised learning. Okay, where will text analytics fall under? Text analytics. Where will it fall under? Will it form part of supervised or unsupervised learning? Text analytics. Hello, class. What do you find in your search? What is text analytics? Let me spell that, text analytics. Class, hello. Oh, first, define what text analytics is, class, and how is it used? Am I still on? Okay, thank you. Waiting, class, for your feedback.
Sir,
Yes.
text analytics is the quantitative data that you can obtain by analyzing patterns in multiple samples of text.
Okay. So does it fall under supervised, unsupervised, or reinforcement learning?
So I think
Could you repeat the use of text analytics?
text analytics is the quantitative data that you can obtain by analyzing patterns in multiple samples of text.
Okay. So what's one example of this? Could you cite examples of text analytics, and will this fall under supervised, unsupervised, or reinforcement learning? Can someone give an example of text analytics? Class, hello.
Sir, I have a question.
Yes.
Does text analytics is it different from text mining?
Mining kasi, well, loosely speaking, it can also be, it can also refer to mining. It's a very loose yung term eh. Some call text analytics as text mining.
Okay, sir, thank you.
Okay. Oh, you can't find any information, class? The internet is awash with so many information about this.
So for an example, I found text analytics
Okay,
could
sandali,
be
sandali. Sorry, who's this?
John po, sir.
Sino?
John po.
John, okay. Thank you, John. Sige.
Text analytics could be classified under supervised learning po. For
Okay.
example, when the model is trained to get data from customer reviews, you could put a
Yes.
labeled positive reviews, negative reviews, or
Okay.
neutral reviews. So,
Okay.
supervised po yung data since nilabelan mo na yung mga classifications.
Okay. So,
It's
okay.
supervised learning po.
All right. That's one case of where text analytics is considered as supervised learning. No? So, ang sabi nga ni John, you mine the data, you get sources of, let's say, comments. No? Kunyari comments from, let's say, Amazon. Yung comments about the product. So you can mine that. You can draw out the comments. There are thousands and thousands of comments about a particular product. So pwede ma-classify yon either as pwedeng satisfactory or not satisfactory or uh, uh, unsatisfactory, etc. So this time, ang ina-analyze is the text itself. So machine learning can also be applied to analyze text itself. And I wanted to to illustrate that as to distinguish that from analyzing only, let's say, quantitative data, no? Tabular data, data that's arranged in a matrix form, rectangular matrix. Pwede ring data lang, no? As I said, getting the comments from Amazon or from eBay or from whatever posts, okay, and then making something out of those comments, or it can also be used for, let's say, for newspaper articles. Okay, we mine the text and try to make sense out of what, let's say, what journalists or what editors or what writers think about a particular topic. Okay, so that's just one example, and this is a growing field. So what I wanted to point out here is that machine learning has grown by leaps and bounds, and its applications can be huge. No? So kunyari, itong anomaly detection, ginagamit na sa financial services yan. Sa mga banks, for example. Kung may may mga transactions ba na unusual, okay, ginagamit ito sa bank fraud, no? Yung anomaly detection. Okay? And many others. We can think of machine learning also ginagamit sa operations, sa manufacturing. Even sa yung mga driverless cars, machine learning yun, application nun. Those are applications of machine learning tools. Okay, so there are lots of applications. Okay, so it's important, class, that at least we're putting here the seeds of machine learning. So marami pang applications yan, and I'd like to encourage you to not only learn R but also learn Python. Kasi Python is the software of choice in the field of machine learning. Pero R is also very powerful. Okay, so let's go now to our lesson for today. So importante yung decision trees. So we're going to use another package which is Fast and Frugal Trees package. Now, ito, no? Dali. Are you familiar with Malcolm Gladwell? Have you heard of his book, The Tipping Point or Blink? Who among you have read this? If not, class, I would encourage you to read that kasi magandang book yun. No? It's a short book. Di naman siya mahaba. No? Tipping Point by Malcolm Gladwell. Okay? He talks about the snowball effect. Yung any intervention, any change, dadating ng isang critical mass yan, it will reach a certain critical mass, which he called the snowball effect, and then there's no turning back from that. Maraming technology ang ganun. It reached a tipping point. So you think we will ever go back to that time na walang internet? I don't think so, Gus. I don't think so. The internet is here to stay. And it will, of course, keep on improving over time. And then you have the chat GPT, na artificial intelligence. Okay. So unless something really drastic happens, I think internet, artificial intelligence is here to stay. So yun yung sinasabi ni Malcolm Gladwell na tipping point na pag ano niyan, it reaches a critical mass, there will be a snowball effect. Tapos hindi na siya no turning back na yun. Okay? So dito sa book na yan, sa Blink na book ni Gladwell, sabi niya, may misconception na about decision making. Sabi niya, it's an urban legend or a folk wisdom that if you have more time, if you have more information, and you put in more effort to your analysis, then your decision gets better. Okay? So in the realm of business decision making, more is better. Okay, but that's not usually the case. More is better, pwede rin, well, sa medical test, di ba? Pwede natin sabihin more is better. The more we know about the condition of the person, whether whatever test you're going to take, perhaps the better decision the doctors will have. So investors sa stock market, ang general rule is that get as much data as you can and build a statistical model that's very complex, okay, so that it describes the past perfectly. Okay, kaso nga lang, I think I mentioned this to you before, there's a problem with that kasi that will be overfitting. And ang problema ng overfitting, yung noise ng past values, okay, yung mga noise niya, kasi hindi naman perfect yung data eh. Even the noise will be modeled. So that when you run a new data to that model, a data that the model has not yet seen, then it will wreak havoc on its forecast, on its predictions. Okay? So kasi nga, masyadong overfit yung data. So in that regard, more is not necessarily better. And my research, no? My research yung nagsasabi na that the more is better theory is in many real world decisions flat wrong. Oh, surprising, no? So hindi pala totoo na the more is better always. There are some instances na less is better. In contrast, there are many cases where he was the writer of that journal, si Dr. Giga Renzer, less is more. And there are two reasons for that. Yung statistical reason is that, yan, ito yung sinasabi ko kanina na overfitting, which is not good. When a model is very good at describing one specific past data set, but fails in predicting new unseen data, then that's what we call overfitting. So hindi maganda yung ganun. Kaya nga, you remember, when we started learning machine learning, when we started our studies on machine learning, we did not use all the data. Okay, we split the data into a training data set and to a testing data set. And on Friday, we're going to learn how to split more. There's this process called cross-validation. Dito yung data, we're not only splitting it 2 times, we can split it 100 times. Okay, kasi pag ganun, when we use robust method of splitting your data and generating the models out of this several types, several samples that we're generating using cross-validation, then your model becomes robust. And nagiging robust yung model. Okay, so for example, a complex economic model that describes changes in the past, in stock prices very well, will be largely unable to predict future changes. Bakit? Bakit? Kasi minodel masyado yung masyado na overfit na. Okay? So sabi nga ni Malkiel, it's so hard for complex trading algorithms to outperform simple index funds in the stock market. So meron kang very complicated, very statistically gumagamit ng mga exotic models in stat. Pero performance-wise, talong-talo siya na isang simple lang na index fund. Okay? Tulad sa index fund, kaya index fund ang pinapagawa natin. Okay, the simple index fund outperforms that which was modeled using trading algorithms na napaka-complex. No? Okay, isa pa. Okay, even if a complex model is good at predicting new data, if a person can't understand it or easily implement it in a real-world decision, okay, example, isang doktor kailangan mag-decide na kung ooperahan ba to o hindi, matter of life and death. You mean to say, pupunta muna siya at kukuha ng data tapos Of course, that's rank stupidity, di ba? Hindi na gagamitin yon. So, yung utility ng ganyang ka-complex na model na kakailangan ng more data, more time, more understanding, more modeling, more tests. In many instances, hindi siya practical, no? Kung pwedeng mas yung model, mas simple, okay? then why not? Okay, so there's this package developed by sino naman, no? Si Giga Renzer noong 1999, dinevelop nila tong FFT, Fast and Frugal Trees. Okay, so ito very fast decisions based on usually few attributes, no? Few variables, and then it will ignore all the other information. Okay, yung FF3 na package, it's non-compensatory. What do you mean by non-compensatory? Okay, it makes a decision and no matter if there's any additional information, hindi mababago yung decision na yun. Very simple to use, no? And they are used in real-world decision tasks. Yun, sa medicine, magko-coronary bypass ba? Diba yung mga ganyang decisions? Hindi naman pa pwedeng gagawa tayo ng model pa muna. Ay, doc, we'll have to submit this to statistical test in order to check kung pwede na siyang magganyang ano. Okay. So, psychological and even in finance, no? May mga applications ng FFT. Okay, as I stated here, research has shown that FFTs can outpredict more complex models in decidedly non-human simulations. Okay, so may findings sa ganyan. So may advantage ang FFT. However, walang mga off-the-shelf methods eh. So we'll have to use yung package na FFT. Alright? So anong pwede natin makita sa FFT na object? We can take a look at the underlying trees. Parang decision tree din to. No? Then we can look at the classification statistics, yung mga misclassifications. Okay, pwede rin yung classification nito, pwede rin ginagamit for logistic and for regression. Okay. All right. So let's install first. We haven't installed before. Paki-install muna yung ano. I'm not going to install it kasi I already have that. But after you install the FF3s, kindly load that library FF3s. Okay, so I'll give you a few seconds to load the package, install that packages. You can use Pacman, of course. And when you're done, class, when you have loaded the package, kindly chat yes, please, so that I know. Okay, thank you, Carlos. Let's wait for the others. Okay, thank you, John. Okay. Let me pause recording. All right. So as I was saying, how did I generate this this list of data sets that are available in FFTrees? Okay, I use the VCD package, and then I use the datasets function, and I identify the package where I wish the list of available dataset to be generated. Okay. All right, and then we're going to use this heart.test and heart.train for our training and testing dataset. Okay. So let's now view our dataset. So i-view nga natin yung ano, yung heart.train and then the heart.test. Let's view that. Okay, so let's just view it. View heart.train. Okay. All right. So you have here heart.train consists of 150 rows of observation. We have the first variable here, diagnosis, and then you have the age, the gender, chest pain, fasting blood sugar yata to, fasting BP, okay, etc. So these are medical or medical observations, no? And then what we'd like to do is to predict, given some of this, given these variables, if we can predict if the person has heart disease or not. No? All right. So let's also look at this is now, on the other hand, this will be our heart.test. So we're going to model we're going to use this object. And this object. And then we're going to create a model for this object. And then we're going to check whether that model is good even for this heart.test, this testing data set, a data that it has not yet seen, right? So sige, run natin to. Yeah, how about the for heart.test, the same, okay? Same variables. Okay, so here let's now create this this model. No? Okay, so I'm going to write here. Let's create this object heart underscore FFT. Okay, and then we're going to use the FFTrees function. Ito yung workhorse, di ba, ng FF3. So let's use formula is equal to diagnose. This is your independent variable, a dependent variable. And then for those of you who haven't used R for prediction, for regression, okay, this tilde is a signal that you're doing regression. And then we'd like to include all the variables so we can identify all the variables one by one. Susulat natin age plus sex plus CP plus, kaso mahaba, no? It's long. So if you're going to use all the variables, you can just type that, okay, and comma. That means that the dot there means that you're going to use all the variables. You're going to regress, diagnose on all the variables. Let me just, okay, comma, and then here, okay, let's identify what's our training data. Our training data is equal to heart.train, right? Okay, comma. And then we're also going to identify our testing data. So it's data, let's move this back. Data.test, that's the syntax. There, data.test. We're going to identify our testing data, and it will be heart.test. Okay. And then let's just give a label to our plot. So let's call it main is equal to, let's call it emergency room decision. Close natin, comma. And lastly, we identify our decision labels. Okay, so let's decision labels. Ayan, no, lumalabas decision labels, FF3s is equal to C, concatenate natin stable, and merong heart attack. Okay, so let's see. Close, and then I need to close this. You can put it here. Okay, you can put it here or you can put it here. Okay, so that shows us ito yung opening, ito yung ending na parenthesis. Okay, so kindly chat this if you were able to generate this already at the time na. We were able to finish this in the other section, so I'll just also post that recording. No? Kasi ito mukhang hindi natin matatapos eh. Okay, if I print this class, saan ako nagkamali? Saan yung mali ko? Comma, heart.train, data.test, heart.test. Tama naman to.
Sir, I think
Ay,
diagnosis
sorry.
dapat
Oh. Oh, thank you. Mali yung variable ko. No? Thank you, John. Yeah. This is not diagnose, but diagnosis. There. Okay, good. Thank you. And if I run this, yan, okay na. Okay, so it gives us a summary of, ayan, tinetest niya, no? Tapos sabi niya dito, okay, meron siyang 7 FF3s na define. We'll take a look at that. No? May 7 FF3s siya. Successfully fitted comparative algorithms. Okay, let's print this. So heart underscore FFT. That's our object, di ba? Run natin. Okay, this is the title ng main, di ba? ER decision. 7 FFTs predicting diagnosis. Okay? So, sabi dito, ginamit niya yung si THAL, si CP, at saka si CA. Tatlo lang, no? It only used 3 variables out of the so many. So, out of the, ilan to? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Out of the 13 attributes, out of the 13 dimensions, it only made use of 3. THAL, CP, and CA. So, ito yung, ano niya, ito yung decision niya, no? So, remember, ito yung classification error, no? Yung decide niya na, nag-decide siya na stable plus, stable na nga, stable yung nangyari, no? Or ito 66. Okay, but let's plot this, no? And then you have here the metrics, no? Andi dito yung accuracy, 80% no? Accuracy. Okay, and it's better, I think, to visualize this. So, i-plot natin siya. No? Let's plot heart underscore FFT, right? And then let's use it for the data. Data is equal to train. The original na data, no? Yung training data set natin. If we plot this, okay, heart, okay, mali ako dito. Very careless of me. underscore FFT. So it's almost time, class. Let me just finish this. Heart underscore FFT. Dito mali ako dito. Sorry. Dapat ito may quotes. Data is equal to train. This should be okay. All right. Then, okay na. So let's see what it does. It gives us the output this time in a pictographic form. Okay, so very quickly, tingnan natin to. What this gives us. This is your fast and frugal trees. All right, there are 150 observations. Ang breakdown nila dun sa origin, sa data na to, 84 are stable and 66 have heart attacks. That's the actual data. So dito, yung decision niya, okay, correct, yung blue, yung green, tapos yung mali, yung red. No? So ito, ang predict niya na stable. So this was predicted to be stable. Okay. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So we start with this. 7 frugal trees daw, no? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Ano ba yung bilang nyo dito? 7 dapat. No? Okay, 1, 2, 3, 4, 5. But 6 lang. Okay, anyway. These are the trees kasi, no? 1, 2, 3, 4, 5, 6. Pero sabi niya 7. Okay, anyway. So dito, class, what happened here? It was predicted to be stable. At this level, 55 yung predict na stable, 8 yung hindi stable. Okay, 11 again, here, stable. Na 4, hindi naman stable. So ang tamang prediction niya dito, 55 plus 11, 66 here. Ang maling prediction niya, 8 and 4 here. So predict niya as stable, okay, is all in all 78, no? Of which 12 are wrong. Predict niya na stable, lahat to is 78. 66 tama, 12 mali. Predict niya na na may heart attack, okay, ilan to? 16 plus 47, that's 63, plus 9, 72. 72 yung predict niya na magkaka-heart attack. Ito yun, no? Ito. Of which 47 plus 7 are correct, so that's 54. 18 yung mali, 16 plus 2 were wrong. Okay, so next meeting we're going to continue with this. Pero tingnan niyo accuracy niya, no? 80% accuracy. ACC accuracy yan. Where did we get that? Where did we get the accuracy? How many corrects? 54 plus 66 divided by how many? What's the total? What's the total respondents? Total respondents is 150, right? How many are correct? 54 plus 66, that gives us 120. 120 divided by 150, that gives us an accuracy of 80%. So meron pang iba dito, sensitivity, specificity, which we're going to discuss next meeting. All right? So we'll finish this. There are a few more. I'm going to share with you this discussion in the other section. Kasi medyo natapos namin to. May one or two na lang yata. Okay. So with that, class, thank you so much. I'll stop recording now.